Hello to everyone, welcome to last option. This is a llNAGARJUN series. This question is related to photoelectric effect, photoelectric experiment or Hertz experiment. For the matching of theoretical idea with the practical observation, we consider the particle nature of light, and by considering that we are going to get 100% result. So that means particle nature in this case is right. However, for this case, consider the wave nature of light. That means what happens if a wave nature of light dominates over the particle nature of light in case of photoelectric effect. So in this question we are having one metal whose area is A and its work function is phi. That means total phi amount of energy must be transferred to the electron in order to get it out of the metal surface. Note that here we are considering the wave nature of light. So energy transfer won't be instantaneous for this electron as it is in the case of particle. Rather, it would be continuous for this electron. That means we will supply a small amount of energy to this electron continuously, and it would stay there until it get this amount of energy. As it get this amount of energy, it will get out of the metal surface. So for the ejection of electron from this metal surface, I am going to incident a light of intensity of I and power P. That means energy per unit time is P and energy per unit time per unit area is I. So this is going to fall normally onto the metal surface. As we are considering the wave nature of light, so one twist is given, that is polarizer is placed in between the path of light and the metal. So light would get polarized, wave nature. So its intensity won't be I for this metal every time, rather it would be changing, and one more twist is given, that is it is keep on rotating onto its plane with a constant angular velocity of omega. So light, polarizer and a metal surface. So you need to find that how many times it would have rotated onto its plane since till the first electron get out of the metal surface. Hope this question is clear. I would also write this question in the chat in the description so that you can have a good idea of questions. So next move to the next one. Consider the second question. It's related to maths field. Here you have to find what is the value of this integration, that is integration of n to the power of dx upon dx, where n belongs to real positive number. So this is quite interesting, you would find it, and some other ideas are going to use in this way. So try this question, you will enjoy it. This question is also from maths field. Here one function is given, that is x square y square equal to a square y square minus x square, that is whole in the bracket. Then you have to find what is its slope at 0, 0. That means differentiation at 0, 0 point, where x and y both are 0 for this point. So that you have to find, and thing that given is a is greater than 0. It's positive. So this is going to be quite challenging, not challenging, rather in case of calculation it would be challenging, but concept wise it's good. To the fourth question. This is also from math, and this is the question from differential equation. Question is dy by dx plus y e to the power t d alpha upon dt equal to 1. So you have to find what is the end result, that is after combining all those things in the mathematical form, what you will get at the end. So the thing that is going to be important is here t and alpha are independent of x and y. So that means they don't have any relation with x and y for this equation. This is going to be challenging but interesting one. Nice. So this fifth question, this is from physics. So in this question we are having two equal masses that are at a distance of 2r from each other, and they are rotating on this plane with the velocity of v naught. That means when they are at the distance of 2r, they are going to rotate about this center of mass. That means about their center of mass they are going to rotate with the velocity of v naught, and due to the gravitational attraction they keep on reaching toward their center of mass, and then you have to find that what would be its velocity when the distance between these two bodies are r. That means what happens when they are at a distance of r from each other, what would be their velocity of rotation. This v you have to find. But one more thing you have to consider is mass is relativistic. That means mass is going to change as velocity changes. That means if we are having 1 kg of ball, it's not going to same if I am in a motion with respect to someone. That means if there is relative motion between the bodies, then there would be relativistic change in their mass, and that relativistic change is given by this equation. But simply we can write it as m equal to m naught times of 1 minus of v square upon c square. So m naught is rest mass. That means the mass when the both observer, that means both a moving body and the observer are at rest, and this mass is their new mass when that body is moving with respect to the observer with a velocity of v. So this is quite challenging one because this is somewhat new to many one, but you can try. It would be a very good example for you. So the thing is, it's rotating with a v naught. You have to find what its velocity when they are at a distance of r by considering relativistic mass. So this is all about today's Nagarjun question. I will be posting this solution of all these in the next upcoming Tuesday. So all the best. Hope you like this video. If it's so, keep on subscribing and we are going to meet next.